Alright, the third lesson for Unit 12 is the tangent graph. The tangent graph is nothing like sine and cosine. This one's going to feel a little bit weird, but pi over 6, hopefully 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay, so that's what you would get if you converted the radians to degrees. Sine of 0 we know is 0 and the cosine's 1. Sine of 30 is a half. Cosine 30 is root 3 over 2. Sine 45 is root 2 over 2. So is the cosine. Sine of 60 is root 3 over 2. Cosine is 1/2. And remember, for those of you who haven't memorized these yet, you need to. Sine of 90 is 1 and cosine is 0. So we know that tangent is sine divided by cosine. You're supposed to memorize these too, but 0 divided by 1 is 0. So tan of 30 is root 3 over 3. Tan of 45 is 1. Tangent of 60 is just root 3. And then tan of 90, sine divided by cosine, 1 divided by 0, is undefined. And anywhere you get an undefined, you are going to get an asymptote. Okay? Now, the other thing I need to note is that the normal period of a tangent, which is down here, is pi. All right? The normal period for a tangent is pi, not 2 pi. All right, so there's no frequency issues with this one. This is going to be a standard tan graph from negative 2 pi to 2 pi. So we are going to count by pi halves because those are the quadrantal angles. They don't mess around with the period and the frequency. We don't have to mess around with our typical labels. All right. There's no amplitude on the tangent graph because it does something unique. All right, so tan of 0 is 0. And then the next one is pi halves, which says undefined. And I said that's where we were going to get an asymptote, but we were going to get a vertical asymptote here. Okay. And then if I go over to tan of pi, it's 0 again. And if I try to do the tan of 270, it's undefined again, so I get another asymptote. And the tan of 2 pi is the same as tan of 0, and I get 0. So kind of an interesting graph. We get points and dotted lines. Well, we're going to get the same pattern on the other side, so without even thinking about it too hard, I'm just going to follow that pattern. But that's not all we're going to get, because if we look at the tan of 30, it has a value, square root of 3 divided by 3, which is a number less than 1. Tan of 45 is 1. Tan of 60 is root 3, which is a number larger than 1. So what happens between 60 and 90? Well, you could type it into your calculator. Here, I'll type a few in for you. Tangent of 70 is 2.7, which is bigger than root 3. And if I do tan of 80, I get 5.6. And if I type in tan of 85, I get 11.4. And if I type in tan of 89, I get 57. This is getting really big in a hurry, but yet when I get to 90, it's undefined. Well, what's going to happen, like with most asymptotes, is our tangent is going to go up from 0, and as it approaches that, I held my pen down, sorry. As it approaches that asymptote, it's going to go really close to it, but not hit. So the first part of our tan graph looks like that. All right. And if I went in the negative direction, it's going to be the same thing, but let's see. And if I go between 0 and negative pi halves, that's talking about 0 and negative 90 degrees. That's the fourth quadrant, okay? There's 0, there's negative 90 degrees. And I know that the tangent in the fourth quadrant's negative. So instead of my arrow going up, it's gonna go down. And right there, that pattern with the down and up is one cycle of tangent. So at the next 0, I'm going to go up to the right, down to the left. And on the next one, I am not going to go up to the right, because if I go up to the right, I'm graphing it past 2 pi. So I'm just going to stick with down to the left. And that finishes off that part of the graph. So if I go back over to the negative side, where I have a 0, I'm going to go up toward the asymptote, down toward the left asymptote. And then at negative 2 pi, I'm going to go up to the right asymptote and stop, because that's as much of the graph as they want. So I actually have multiple cycles of the tan graph here. Okay, so in between pi halves and 3 pi halves, which is a whole pi, I get one full tan graph. All right, so the period of a tangent is pi. We're going to skip the graphing calculator exploration. You could do that if you want, but if you graph a tan on your graphing calculator, first of all, remember it needs to be in radians, but second, you're not going to like what you see, because the calculator has a really hard time drawing the asymptotes, and it just ends up looking like an EKG when you're done. But all the amplitude does is make your graph go up faster, so you get a steeper line, or a steeper curve. But now if you're given y equals tan of 2x, the 2 is the frequency, and that says you're going to graph 2 tan graphs by the time you get to pi. We are not going to do that. So far, the Regents exam pretty much sticks with just regular tan graphs, so we're going to stop and not graph that one. But the example 1, they will do this to you as a multiple choice question. What's the period of this graph? The thing you got to remember is the period of a sine and cosine is 2 pi, but the period of a regular tan graph is just a regular pi. So for a tan graph, the period is pi divided by frequency, and so your period's pi fourths. Okay. Cotan graph still has a period of pi. Cotan is the reciprocal of tan, which is what you get when you flip the tan values. So it's going to look like its graph is flipped. So we're going to do pi halves, pi, 3 pi halves, and 2 pi. Now we know that the tan of 0 is 0, sine divided by cosine, but cotan is that flipped, and when you flip a 0, you get an undefined. So a cotan starts with an asymptote on x is 0, which means the next point is going to be a 0, and the next one's going to be an asymptote, and the next one's going to be a 0, and we're going to end with an asymptote. So it's the same pattern as tan, but shifted over one place, if you will. And now we also said cotan is flipped. So instead of going up to the right, it's going to go down to the right, because it's flipped over, and up to the left. Down to the right, up to the left. There's our cotan graph. So period of a cotan graph is just pi. All right, a few little multiple choice questions to try, and I am going to cross off the tan 1/2 x. I don't want you to do that. You can try the negative tan x if you think that's too rough. Just see if you can do the tan x by yourself. And yeah, we're going to take the 2 out and just see if you can produce a cotan graph from negative 2 pi to 2 pi on your own. So make some additions on the homework. Challenge problem there. Well, I don't know, for anybody who's got internet, you might want to look up and see how to do that. But hint, that's a transformation. Remember what you did with transformations and see if you can figure it out. All right, good luck on this homework.